Everyone, welcome to my YouTube channel. Today we are going to solve the today's problem of the day of Geek for Geeks. So question name is check if subtree. Question says that given two binary trees with roots root 1 for tree T and root 2 for tree S, each containing at most n nodes, determine whether the tree S is the subtree of tree T. Return true if S is subtree of tree, otherwise return false. So there is a note that a tree S is considered a subtree of T tree if there exists a node in T such that the subtree rooted at that node is identical to S. Two trees are identical if they have the same structure and same node value. So question is simple that we have provided two trees, and both tree in from both tree we have to check whether the one is the subtree of other is not. So always we have to check that root 2 tree is the subtree of root 1. So for that the condition is applied that we have to check whether node present root node presents inside the node or not. If that are present, then both node having sharing the identical tree or not. So we have to check that. Let's take the first example. This example we can see that 3 and 4 are present inside this first tree, so we can say that tree is the subtree of that particular, so we will return true. In the second example we can see that both tree are identical, so both are subtree of each other, so this is also true. And so we can write the code for the same. So we have what we have to do, we have to check whether the node is present inside the node tree. If it is present, then we have to check whether both are sharing identical tree. If that is true, then we can say the tree is subtree, otherwise we can return false. So for that we can write the base case. If not root 1, we can just directly return false. And before that we can check that if not root 2, if what we have to check for subtree, that is the base condition. If it is not root 2 is not present, we can return true. Okay, what we have to search that is not exist, then we can return true. If from where we have to search, if then it is not present, that was the tree was not present, then we can return false. After that we have to check if root 1 comma root 2, for we have to check if root 1 and root 2 are identical or not. So we will pass both root 1 and root 2 in our function. The function name can be is identical, and we are passing both tree roots of the tree in our function parameter, and whether our function return true. If the function returns true, then we can say return true, otherwise we can return the condition with the uh, for the left and right child. So we can return self dot is subtree. We can call it recursively by passing the next value of root 1 dot left. We will compare it with root 1 dot left and pass here root 2. And if this may be the tree, or the right may be the right may also be the tree, so we can call the self dot is subtree root 1 dot right comma root 2. In this way we can recursively call both the left and right of the tree with root 2, and we will search for the identical. So after writing this code, we have to define the identical. So let's define the identical function. Is identical. What we are doing here, we have to check whether both tree are equal or not. So we will pass two roots. Let's write root 1 comma root 2. We have to check whether the root 1 is equal to root 2. For that we will check if not root 1 and not root 2. If both are not present, then we can return true, both are equal. If one of them is present and other is not, so we can say if root 1 not root 1 or not root 2, If one of both is present, then we can return false. Okay, and we have to check whether both are identical or not. For that I will recursively call the is identical function for both the left and right child simultaneously, so we can return uh, is identical is identical is identical, and we will pass root 1 dot left comma root 2 dot left, and this should also be true, and with this condition right also be true. That for that is because we have to check identical. So identical of is identical of, we will pass root 1 dot right comma root 2 dot right. If both condition are true, and then only we can say that tree is identical. So let's try to run that. So there is a runtime error, let's check. Okay, so I got the mistake that we have written here subtree in place of subtree. We have written subtree, and another thing that we have to compare the data also. So we will compare if condition would be that if we have to compare the root 1 dot data is equal to root 2 dot data. Both values must also be the same, and we have to pass left and right both. So let's try to run it. Yes, there is more mistakes, let's check it. So it should be root 2 dot data, not root dot data. Okay, now check it. Yeah, we have passed the cases, so try to submit that. Okay, so we have solved the question. Thank you for watching. Hope you understood that is the very simple approach that we have applied as the question says. We have to use this and try to simulate the question. We are using a recursive approach. So the complexity of would be the big O of n would be the maximum number of nodes in root 1, and there is no any extra space we have used. So there is a recursive approach, so internal stack memory is also used, but not external any space. Thank you for watching. Hope you understood that. Bye bye, take care.